So this is your question number 5. For your information, I will skip to discuss the question number 4 because I believe you can find the solution by yourself and understand it by yourself. If you need an detailed explanation from me, you may ask me to explain to you during our first class. So this is question number 5. A question give you a wheel over here which combined with the piston. This is a part of engine in car or motorcycle. You are given the radius of the wheel, which is the symbol is A, is equal to 0.25 meter. It rotates with angular frequency omega is equal to 12 radian per second. You know that this omega over here is related to period and also related to your velocity. Now, when t is equal to 0, which is time is equal to 0, it is given that the x of the piston is equal to a, which is the original or the rest point. So a question given to you to find the positions, the velocity and the accelerations of this wheel over here or the piston over here when t is equal to 1.15 second. So I already take out all the information for you over here. You have your radius or a maximum amplitude of the piston. You have your angular frequency. You have your time and the positions of the piston when time is equal to 0. So you were asked to find the position, the velocity and the acceleration when t is equal to 1.15. Now to answer this question, you have to start with the general equations of SHM. So I believe you did, Madam Uzaika did explain these equations to you in your lecture hall, but then we recall it once again. So the general formula of SHM was that as this one. It was a distance equal to the amplitude, which is the maximum point of the wave or the minimum point of the wave, cos time with the cos times with the omega, which is our angular frequency, times with times. So this is displacement. This is the equations of displacement, also known as the general equations of wave. Equations of wave. So from this displacement, when you know how to derive the displacement to your velocity and the acceleration, you're supposed to have no problem to answer these questions. So as you know, to find the velocity, I have to change the value of x and divided it by the time. So similar in this case, when I derive or when I differentiate the value of x towards t, which when I differentiate this equation towards t, it's supposed to produce an omega. So that omega will times with my amplitude, and when I differentiate cos over here, suppose I will get negative sign. So this is the rules of mathematics. So I hope you know these basic derivations, and then come with the omega t. So simplify it so that the negative sign over here, you can bring it at the front of the amplitude, so it will become the negative amplitude times with the angular frequency sine omega t. This is the equations of velocity in SHM. So similar with accelerations, where to find acceleration, I have to change the value of velocity towards t. So similar in SHM, to find the acceleration, I have to differentiate once again the value of velocity to time. So when you differentiate these equations over t, you will once again get the omega over here, another omega. So you will get negative a omega square. And then when you derive sine to cos, when you derive the sine value, you will get a positive cos and come with the omega t. So you will finally get the equations of simple harmonic motions or wave for the acceleration, which is also equal to a negative a omega square cos omega t. So this is the value of acceleration in SHM. So remember everyone that you have to know these three equations in order for you to understand or in order for you to answer this type of question. Some questions or previous questions in midterm, we did ask about the derivations of these three equations. So be careful on that one. Please pay attention to the derivations of these three equations. Now we continue with the questions. Since I already derive all the equations for you, so just substitute everything into each of the questions with the t is equal to 1.15. So the positions can be found by using this equation, which is our general equations. So my A is equal to 0.25 meter. It was given to you. Cos, and then omega also given to you. So it is 12 radian per second, and then time is 1.15 second. You finally will get the value of x is equal to 8.27 times of the negative 2 meter. So this is A. And then B also need to find the velocity. So by differentiate these equations, you will finally get the equations of velocity, which is negative a omega square. A omega sine with the omega t. Once again, substitute everything. You will finally get the value of velocity is equal to negative 2.83 milli per second. Last but not least is the acceleration, where the equations, when differentiate the equations of velocity, you will get a omega square cos omega t. Substitute, and once again all the information given to you, you will get the answer of acceleration is this one.